So look at the structure above. So you have a member AB and a member AC. So between B and C, angle phi is there. Then you have angle theta too. That is what you have. Then angle phi is given to be 40. So the question is, you determine the sine angle theta. Theta is what you are looking for. You're looking for theta. That is the first thing you're looking for. So the second thing, you now find the components of force acting on member AB. These are the two things you're looking for. Now, to determine the angle theta and the component of force acting on member AB, you need to draw a parallel line to AB. Why? Because this force is going in this direction. And from the questions, you are given AC. So AC is given to be 500 lb. That is the reason why you have to draw the line in this, so that this line should be parallel to AB. So it's very important. And let's get the line now. So the parallel line, so AC is parallel to AB. So easily you can transfer this angle down to this place. Here is also theta. So that is corresponding angle. This angle and this angle are corresponding angle. Then this angle is also equal to this angle. So this place is an alternate angle to this place now. That is what you do. So you are working with triangle ADC. That is what you're working with now. ADC. So whatever you have on DC is same thing as AB, because the two of them are parallel. And let's get the sine angle now. So since you have your AC and you have your AD, so you are given two sides, then an angle is needed. So you have to use sine rule. That is what you are going to use to get your angle, the sine angle. So let's get the sine rule done now. So you have it to be AC over sine D equal AC over sine D. AC is given, sine D is needed, then is equal to this place, which is equal to AD over sine C. That is your sine rule. So don't forget, phi is given to be 40, so you have to put your 40 here. And let's go now. AC is 500, so you have 500 over sine D, which is a sine theta. D is theta, looking for theta, equal AD, which is 400 over sine C, which is a 40 degree. Phi is 40, which is given. So you're looking for sine theta. You can multiply, you divide both sides. So you have 400 sine theta equal 500 sine 40 degree. Then your sine theta now is equal to 500 sine 40 all over 400. And don't forget, you're looking for theta. So your theta now is now equal to sine inverse of 500 sine 40 degree over 400. That is what it is. So just take a calculator now. You press it. The sine inverse of 500 sine 40 divided by 40 is equal to 53.46 degree. That is what the sine angle is. So this angle theta is equal to 53.46 degree. That is the angle you have here. So you got the angle now. So you got the angle 53.46 degree. So this angle and this angle, they are equal. Corresponding angle are equal. So this angle is equal to this one here. Alternate angle are equal. Why? Because this line here and this line are also parallel. So you can relate things in that order. Then from there, you can go on and get the component of force acting on member AB. So you can't do it from this direction. So you have to use this place. So you calculate the component of force acting on member DC. So whatever you have here is equal to that of a member AB. Why? Because this line and this line are parallel. So to do that now, so you need to use cosine rule. Cosine rule is what you have to use to get that one. Cosine rule is what you must use to get it. And to use cosine rule, so this angle is extremely needed. So you need this angle. This angle and this angle, they are useless. Since you're looking for the force on this one, this is the angle that you need. You can't use any of this. So you have to find this angle. To get this angle is very easy. So when you have a triangle whereby 2 out of the 3 angles is available, you can easily get the third one. By having the 2 available, you remove the result from 180. So that is it. So to get angle A, look at it now, is equal to 180 minus, so this angle which is 40 plus this angle which is 53.46. That is what you do. So that is what you do. So by the time you subtract them from each other, so you are going to have 86.54 degree. That is the angle you have here. So the angle A is 86.54 degree. This and this added together, 180 minus the result, you have 86.54 degree. That is the angle you have here. So this is the angle you are going to use to determine the component of force acting on member DC. Let's go now. So let's go with this cosine rule now. Cosine rule, this place is what you are looking for now. If here is A, here is small a, you're looking for small a. Don't forget your small a is equal to DC, which is now equal to AB. That is their parallel. So A square, this is the angle, is equal to the side available. This is C. You have C square plus this is D. You have D square minus 2CD, then cos A. That is your formula. You compose the formula. It's very easy. When you compose the formula, everything will be easier. So you go from there, C. That is, this is C. This is side C. You have 400 square plus D. This is side D. You have 500 square minus 2 into 400 into 500. That is what you have into 500. Then cos A, which is 86.54 degree. That is it. So let's solve the problem. 400 square plus 500 square, that will give us 410,000. So you have 410,000. That is it. 400 square plus 500 square. Use a calculator. So you are going to have 410,000. So 2 times 400 times 500, you are going to have 400,000. That is what you have. 2 times 400 times 500 is 400,000. 400 square plus 500 square is 410,000. Then get your cos. Cos 86.54 is 0.0604. That is it. Use calculator for all this. Cos 86.54 equal 0.0604. Then you come down from there. So you have 410 on gram 1000 minus. So this times this. So you multiply 400,000 times 0.0604. So you are going to have 24,160. 24,160. That is what you are going to have. 24,160. So 410,000 minus this. So you are going to have 385,840. 385,840. That is what A square is. But don't forget, you're looking for A, not the A square. So to get A from the square, you're going to take the square root of this one. So A now is the square root of 385,840. So when you get the square root of this one, so the result is 621.16 LB. So you can take it now to the nearest minute. So you have it to be 621 LB. That is it. Nearest. That is it. Then it's done. That is it.